What's up, everyone? It's Jason again. In this series, I'm calling my Quick Hit Tech Tips, as I will be quickly going through individual Siemens function blocks. I'll be talking about their inputs, outputs, and how to use them. I hope you enjoy. Today, we're going to be continuing our series about the Siemens technology objects. As you can see, I'm back in front of my computer and off the road, so I may be on the screen a little bit on this one. We've been talking about these Siemens technology objects, and today we're going to be talking about a block called MC MoveVelocity. So we previously have talked about the basic blocks you need in order to enable and run a drive using technology objects. MC Home, MC Reset, MC Power, and we talked about a couple of move blocks called MC Move Relative and Move Absolute. Today we're going to be talking about MC MoveVelocity, and as you could probably guess, this function doesn't have a position. It is about velocity and moving at a specific speed. So let's talk about this MC MoveVelocity block a little bit. Here are the inputs and outputs. Some of them are similar to what we have in the other technology objects. Just like the axis is what actually ties our technology object to this block, and in this case, we can always drag from our project tree over into our object, and it will make that connection. The execute on this block is a little bit different than the other move absolute and move relative functions, because this moves at a velocity, and so you need to actually maintain the execute bit on this. Velocity, acceleration, deceleration, just as we've talked about before. Velocity is the velocity in engineering units that you've set up in your technology object that you are wanting to run at. The acceleration is your overall acceleration that you'll be using at any time during these moves. Same with deceleration and the jerk. The direction, current, and position control inputs have special meanings specifically for this block. Let's pull up the help file by clicking on the block and hitting F1. Or in my case, pulling up what I've already pulled up before. As we can see here, the direction input controls which direction the axis will move when we put in a velocity. If we have a 0 here, the sign of the velocity will determine the direction. So a positive 100 degrees per second would result in a positive direction of rotation. Negative 100 would represent negative 100. Pretty simple. The next input is the current input. I'll be honest, this input doesn't make a lot of sense in a normal operation, because what it does is essentially locks in whatever speed the axis is moving at that time and just continues moving at that speed. Meaning when you execute the block, click current, it will just continue to run at that speed. The last input that we're looking at is the position controlled input. The help file here isn't very helpful. I can tell you a little bit about the position controlled input from experience. Inherently, MoveVelocity is dealing with obviously the velocity, but there are two ways it can do that. It can either just control the speed of the motor, or it can control a changing position. What that means is if this position controlled bit is false, it is only looking at the speed. It does not care if the position set point and the actual position are not tracking properly. All it is caring about is the actual velocity itself. What does that mean? Well, if you have following error, that is going to be a position controlled error. In a non-position controlled move, it does not have any following error. That can build up that following error in a non-position controlled move. Let's go back to the actual block itself, because it's a little straightforward when you're talking about that. Let's look at our outputs. We have kind of the same outputs that we've had on all of our other technology objects, maybe just with a little bit different terminology. On the other blocks, we would have a done bit instead of an in velocity bit. The difference is, like we talked about before, the execute bit has to be maintained on this block. The in velocity bit is signifying that the set point speed has been reached, or within a window. Just as the others, the busy, command aborted, error, and error IDs function as a way of saying that busy will be active when the block itself is being executed. The command aborted will be true in a time period after, say you have an MC halt or another overriding command, that command aborted will go high. And if for any reason the block errors out or cannot execute, you will get your error high signal and an error ID. And again, if you're not familiar with this, the error IDs are available in the helps. Down at the bottom, click error ID, and here are the explanations for all of the error IDs. This block is fairly simple, and the operation of it is, again, pretty intuitive. The only caveat that I have on this block is that if you are running this block and you change the velocity input, it will not change the actual velocity of the motor. Instead, you will have to see a positive edge on that execute bit for it to change that velocity. Just as with the other motion control functions, we do have what is called the velocity override. And you can click on the actual technology object itself, and then down in your details view, override and velocity. If you change this override velocity, that will actually change the speed in this block. Again, a couple of caveats with troubleshooting this block. If you start messing with that override velocity, you can accidentally set it to 0, and then no matter what you put into the actual inputs of the move velocity block, it won't work, because your override velocity will be overriding so that it is running at a 0% speed. So that is pretty much it for this block. There's not too much more about it. We've talked about all of the inputs, the outputs, how to use it, and again, these are all based around these technology objects that we've been talking about in previous videos. So, if this video has been helpful for you, please like and subscribe for more. Until the next video, I'll see you around.